Good morning and welcome back to the next class of Theory of Computation. In this class, we are going to learn about ambiguity in context-free grammar. So consider the given set of production rules to derive a particular sentence in English. So let us consider an example of a sentence, they are flying planes. So this sentence can be derived by using the given set of production rules in the following manner. That is, a sentence is made up of pronoun and a verb part. Here the pronoun derives to they, whereas the verb part is derived as verb and a noun part. The verb derives are and the noun part derives to adjective and noun, where the adjective is flying and noun is a planes. This is one way of deriving a sentence they are flying planes using the given set of production rules. The same sentence they are flying planes can be derived from the given set of production rules in another way like this, where a sentence is derived from a pronoun and a verb part, where the pronoun derives they, whereas the verb part consists of verb and a noun. The verb part is derives to an auxiliary verb and a participle. The auxiliary verb is are, derives to are, and the participle derives to flying, whereas the noun derives to a planes, right? So these are the two different past tree that can be derived, that can be used to generate the same sentence, that is they are flying planes. So these are two different derivation tree, or you can say two different leftmost derivation. Right, what is leftmost derivation we have already seen in the previous class. So in this two sentence, the meaning of this two sentence is different. Like in the first sentence, they refers to the planes that are flying, whereas in the second sentence, the they refers to the people inside the plane. Right. So in this way, two different derivation gives two different meaning to the past tree or to the sentence. Right. Two different past tree gives two different meanings. This two different meaning thus confuses the user to understand the sentence, because when the user reads the sentence it is same, they are flying planes, but based on the derivation that is used, this ambiguity creates confusion, right? Based on which derivation tree is used to derive this particular sentence, the meaning of the sentence changes. So if there are multiple parts tree, it creates confusion for the user to understand the sentence, right? So ambiguity creates confusion. So a context-free grammar CFG is ambiguous if there is at least one word in the language generated by the grammar, that is L of G, which is ambiguously derivable. Ambiguously derivable means there should be two past tree to derive the same sentence, or there should be two leftmost derivation. So if any context-free grammar have at least one word that can be derived ambiguously, or that can be derived by using two leftmost derivation or two derivation trees, then such context-free grammar is called as ambiguous context-free grammar. Let us consider an example on ambiguity in context-free grammar. Consider the following grammar with productions as P that consist of S derives to SA, SBS. Another production rule is S derives to SB, SAS. And the last production rule is S derives to epsilon. Now, to check whether the given grammar is ambiguous or not, we need to consider a particular string that can be derived in different ways by using two leftmost derivation or two derivation tree. So consider the following string of the grammar as AA, BB, AB. Let us try to obtain different parse tree which are possible for this particular string. Right. So we'll start from the start symbol, which would be the root of the parse tree. And as we want the string to match the following string, so it should start with A. So production rule that would be deriving a string starting with A can be the first production. So we replace this S by the first production rule, that is SA, SB, S. Now we want the string should start with A, so the first S can be made as epsilon. So we use this rule, and always we would be using the leftmost non-terminal to derive. So we would be replacing the first S by epsilon, that is the third production rule. So the string would now be starting with A. Now we want another A over here at the start. So after this A there should be another A. So another string or the production rule which is deriving a at the start is again the first production rule. So this second s, which is the leftmost non-terminal now, it would be replaced by the first production rule, or it would derive to the first production rule again. So we replace this s with sa, sb, s. Now we want that there should be two consecutive a's in the given string. So this s is to be made as epsilon, so we use the third production rule, and this is the leftmost non-terminal, so we replace it with epsilon. Similarly, we want there should be two consecutive b's after this a's, so we replace this s and this s by epsilon again, right? Now the string is matching to this part of the string, that is a b b, as we ignore the epsilons, right? So the string is a b b. Now after this a b b, we want there should be ab. So this production rule which is deriving again ab in the sequence is the first production rule. So the last non-terminal s is again be replaced by the first production rule that would derive us to ab. So we replace it with sa, sb, s, and now this ab is obtained over here. So we want that all these non-terminals to be replaced by the third production rule, that is epsilon. So this s derives to epsilon, this s also derives to epsilon, and this s also derives to epsilon. So now if you read all the leaf nodes which are represented by the red nodes in a sequentially, so you get a string that consists of epsilon a, epsilon a, epsilon b, epsilon b, epsilon a, epsilon b, and epsilon. As we know that epsilon concatenated with any terminal gives you the same terminal or a regular expression. So the string that would be derived is a, b b, and ab, which matches to the given string. So this is first parse string that would be deriving the string a b b, and ab. Now to prove that this particular grammar is ambiguous, we need to derive the same string in another way by using another parse tree or another leftmost derivation. So we will try to derive the same string by in some another fashion. So let us start. Again we'll want that the string should start with a. So we would be using the first production rule itself. So the root node would be the start symbol, and it would be replaced by the first production rule. So s a, s b, s. Now lastly we want ab, so we can consider this ab as the last ab. Now this s would derive us to a b b, this part of the word. So we would replace this s by again the first production rule, so it would give you sa, sb, s. Now we want there should be two consecutive a, so we would first replace the first a by epsilon, so it would give you epsilon. Now there is a, after this a again we want there should be a, so this s would now be deriving to the first production rule, that is sa, sb, s. Now we want two consecutive a over here, so this s is to be made as epsilon, so it would derive to epsilon. Similarly, this 2s would again be deriving to epsilon, so that there would be two consecutive a followed by two consecutive b's. After these two b's we want ab, so this s is again to be derived to epsilon, so it would derive to epsilon, and then ab is there. So this 2s would again derive to epsilon, so the string a b b, ab would be derived. In this parse tree again, if you consider all the leaf node, you would get a string that consists of epsilon a, epsilon a, epsilon b, epsilon b, epsilon a, epsilon b, epsilon, which is nothing but equivalent to a b b, ab. So the same string a b b, and ab is now derived by using this parse tree too. So the same string can be derived in two different ways by using two different parse tree or two different leftmost derivation. Thus we say that the given grammar is ambiguous grammar. In next class we'll look at another example on ambiguity in context-free grammar.